So we're going to do lesson 6, displacement in 2 directions. We were to calculate displacement in 2 directions. That's the goal. So I want you to write that down. We're going to do 2 quick examples, well, 2 examples. I'm going to try and go through them relatively quickly. The reason I want to go through them quickly is, as I said, I want to give you guys a chance to work on some of those questions from motion 1, because as I said, those are due next Tuesday. So getting them done, giving you guys some time in class to do it would be really good. Okay, what did we do last time? Now, if you haven't copied this down, you can access these slides. They should still be on the Google Classroom. If they're not, let me know and I can put them back up. But last time what we did was we talked about, firstly, lesson 4, we did this whole thing where we broke vectors up into smaller components. And then once we turn them into IJ components, we then spent the second half of the lesson learning how to stitch those components together into like 2 meters north or whatever. Then what we did is, yesterday we talked about displacement. What is displacement? We said displacement is a scalar quantity, and it just happens to be how far something's traveled and in what direction. We did this example here to show you how you could calculate displacement. And then what we did is we did one example on displacement here where we said that the displacement was 50 meters to the right, but the distance was 130 meters, because that's when you add all these values together. So what do we need to do with displacement in 2 directions? Well, this is when we use those vectors to our advantage. We're going to do, which one are we going to do first? This one's the easier one. So we'll do this one first. I don't know why I changed the order, but we'll do this one first. So I'm going to quickly write this down on my page, while you guys should probably write this down as well. A ship sails 15 kilometers north, then 4 kilometers east. What is the distance and displacement? Calculate distance / displacement. All right. Now I'm going to cast it from my phone so that you guys can sort of see what I'm doing. And we're going to calculate this together. Guys, as we work through this, I'm going to ask you guys some questions. The longer you guys take to answer, the harder it's going to be to do this sort of stuff. Okay? Because I would normally get input. If we were in class, what I would do is I'd be like, okay, and I'd be like, Magilla, what's the thing? Or I go, Eric, can you tell me how far north it's gone? You know, I would actually pick on students. But because I can't see you guys, I can't really do that. So it puts us at a bit of a disadvantage. So first thing you should always do in a question like this, after you've underlined the important things, is ship sails 15 kilometers north and 4 kilometers east. And then I would normally underline in a different color what do we have to calculate, the distance and the displacement. So now, once you've done that, the next step is to always try and transform that information. That might mean writing it down on the left, but in this case, it means drawing a picture. So it's 15 kilometers north, so my picture is going to have this. And then I'm going 4 kilometers east, so I'm going to go to the right, because if you remember, never eat soggy wheat bix, whatever you want, never entertain sexy women, whatever reminds you, then that's the one. So then that's 4. Notice how these lines are not straight very much. That doesn't matter. And that's what I always try and tell students. They're like, oh, I need to get a ruler. I need to borrow this off a friend. It's like, no, you're doing a maths question. You're doing an engineering maths science question. Just get the picture down. So we've got this thing here. Now the distance is nice and easy to do. Someone tell me, what is the distance traveled? Nice and easy in chat. How do I calculate it and what is the answer? Or you can say it out loud if you can't be bothered writing down in chat. How do I calculate it? What is the distance? 15 plus 4 kilometers. Perfect. 15 plus 4, thank you, Dylan, is 19 kilometers. That is the distance traveled. Don't need to give a direction because it's distance. Displacement, on the other hand, oh, that's going to be a bit more challenging. To work out the displacement, you need to work out how far you are from the start to the end, the shortest distance, which happens to be this line here. Now, to work that line out, we need to do two things. It's a vector, so that means we need to combine these two vectors here, the north vector and the east vector. To do that, well, first thing I'm going to do is I'm going to work out the size. The size is going to be equal to the square root of 4 squared plus 15 squared. Calculator. I'm not going to do this in my head. Square root of 14 squared plus 15 squared gives me 20.52. Kilometers. No. Mistake. Who could tell me, you know what, let's get you guys involved. Where did I make a mistake here? Someone tell me straight away. Yeah, thank you. I did 4. That's where I did 14 instead of 4. Guys, how did I know that I made a mistake? I'll tell you how I knew that I made a mistake. Because the displacement was more than the distance. And I was like, that doesn't make sense. That's not, well, yeah, it's not possible, right? It shouldn't be like, yeah. I knew that I made a mistake. So let's try this again. The square root of 4 squared plus 15 squared. I just started to look at it. That doesn't look right. Now 15.52, that looks a bit better. Okay, 15.52. It's a bit longer than this side here, so yeah, okay, kilometers. But that's not just the displacement. Remember, with the displacement, you need to have a direction. So I need to find out, what is this angle here? If I call this one the opposite, the adjacent, and I know to find this angle theta, I need to go inverse tan of opposite over adjacent, which is going to be inverse tan of opposite, which is 4 over 15. Which is going to be 14.9. Let's call that 15 degrees. So that means, and that happens, remember this is north here. So that means the final displacement is 15.32 kilometers north, 15 degrees east, because north, and we're turning to the east. That's why it's north 15 degrees east. Or you could say 15 degrees true, because if you measure from north, it's just 15 degrees true. I don't know why my phone just jammed just then. But yeah, that was my working out there. So that's how I got to this value here. So that's displacement in 2 directions. Now I've got one more example, and then I'm going to give you guys the last probably 20 minutes to work on motion 1, and if not, I'm going to upload motion 2. So let's switch my sharing back to here. Were there any questions on that? Anyone like, whoa, how did you do this bit? What? Why is it 15.32 and not 15.52? Maybe it is 15.52. I made a mistake because I can't read. Thank you, Dylan. Okay, we're going to do this one here. This is the last one we're going to do. Jot this one down. The reason that we're doing this one, even though it's pretty much exactly the same, is because the direction question for the displacement part is a bit different. Plane flew 5 kilometers north, 5 kilometers south, and 5 kilometers west. We want to calculate distance and we want to calculate displacement. Let's do this. So I'm going to pop open to this over here now. We're going to do the same thing. And the reason that I'm also, by the way, the reason I'm doing this with you guys is because I don't want to move on to the next topic. I want to do that on Tuesday when we've got a bit more time. And I thought, you know, make a bit more sense. Maybe do some examples, get some stuff here. So plane flew 5 kilometers south and 5 kilometers west. Firstly, 5 kilometers south, 5 kilometers west, that's the important part. We want to calculate the displacement and the distance. Let's draw that in. So this time the plane's going south for 5 kilometers and then west for 5 kilometers. Remember, north, east, south, west, done, perfect. So now the distance traveled. Can someone tell me, easy question, what's the distance traveled? Checking in chat. Looks like I'm lagging a bit. 10 kilometers? You're right. Because it's just 5 plus 5. Yeah, don't know why my phone sometimes lags out a lot more than my computer does. But yeah, it's a bit weird, but we'll just sort of assume. So then the displacement, how do you work out the displacement? Well, the displacement happens to be this line here. So the displacement we're going to do 5 plus 5 squared. So we're going to do the square root of 5 squared plus 5 squared. That's going to give us the size of the displacement. Which is 7.07. As for the angle, well, I can tell you straight away what the angle is, but if you don't know how to, just in case, opposite, adjacent, it's going to be, we're going to find this angle here because where we start, inverse tan of 5 over 5 is going to equal 45 degrees. Just in case you don't believe me, which I'm like, why would you not believe your teacher? 45 degrees. Now here's the real question here. How do you describe this angle? Well, this angle you could do in a couple of ways. What I would do is I'd say, well, this is south. So you could say 7.07 kilometers south, 45 degrees west. Or you could write 7.07 kilometers southwest. Why? Because 45 degrees is actually straight southwest. Or you could do this. You could say, if this is 45 degrees and this is 108 degrees, you could say, well, 7.07 kilometers at 125 degrees true. The true bearing is the angle from north. So if you got to add 180 plus 45. Don't care what way you do, don't care which way you do it, as long as each of these three would be correct. And I'm never going to begin, I'm going to avoid giving you guys multiple choice questions where this is the case. The reason I'm going to avoid that is, hold on. The reason why I'm going to avoid giving you guys multiple choice questions is because if you don't know how to do, if you're not confident with doing these kinds of measurements, like these kinds of degrees, I don't care which of these you do, as long as you give me a direction. Right, that's it. So what I'm going to do now